diagram. I still gotta be here too. It's true. It's true. It's true. All right, so let's look at what we getting into now, right? We're gonna do. I am. Yeah. Oh, no, the okay means that it is recording. Yeah. So we doing. Oh, you saying my voice not being there? No, we good. We good. We good.
Not so much.
So what I do is I mute this thing so I don't hear echo. That's why. Right. So we're doing scatter diagrams and linear correlation. This is fun stuff. So studies of correlation and regression of two variables usually begins with a graph of paired data values X and Y. Remember those? Right? And we call such a graph a scatter diagram. So a scatter diagram is a diagram in which data pairs X and Y are plotted as individual points on the grid with horizontal axis X and vertical axis Y. We call the X the explanatory variable and the Y the response variable. All right. So by looking at a scatter diagram of data pairs, you can observe whether there seems to be a linear relationship between the X and the Y values. Let's look at an example real quick. All right. Let's look at an example. Just bring this up. Y'all gonna see this is real easy. Huh?
So a scatter diagram is
Uh-huh.
just a graph with dots.
Pretty much.
So it's basically slope.
It involves that eventually. We're gonna talk about that. Let's look at an example real quick. So check this out, right? So phosphorus is a chemical used in many households and industrial cleaning compounds. Unfortunately, phosphorus tends to find its way into surface water where it can kill fish, plants, and other wetland creatures, right? Phosphorus reduction programs are required by law and are monitored by the EPA if they're still working right now. They part of the shutdown, right? Damn. So I yeah, I guess no, that's the federal government. Yeah, so EPA would be part of it. You know? So what does that mean? Look twice at your salmon before you eat it. You know? The freak?
That's it.
What's happening on my phone right now?
Dumbed down version
Mm-hmm.
of like what's up there, cause I kind of like understand the dumbed down versions better.
Good.
Yes, and
That's
it's
all I want
so
you to understand.
simple. Yeah, look, it just
Yeah.
a
Mhm.
scatter diagram, which is also called a scatter plot, is just a graph with dots. Each dot
That's
shows
it.
one pair of numbers, X and Y.
That's it.
Bottom line is X axis, side line is Y axis.
Yep. Same thing we did already.
Yeah,
Exact same thing.
but you see,
Mhm.
that is like Chinese to me.
Why? I didn't even show you guys it yet. I didn't even show you it yet. All right, so look at this. A random sample of 8 sites in a California wetland study gave the following information about phosphorus reduction in drainage water. In this study, X is a random variable that represents phosphorus concentrations in 100 milligrams per liter. At the inlet of a passive biotreatment facility, and Y is a random variable that represents the total phosphorus concentration in 100 milligrams per liter at the outlet of the passive biotreatment facility. Blah blah blah. Dirty water is going in, clean water is coming out. All right. So here we gonna do, right? What did they say X was again? So what we want to do, let's highlight this. So X is a random variable that represents the phosphorus concentration, right, at the inlet, right? Y is a random variable that represents the total phosphorus concentration at the outlet, right? So, second. Let's say that I want to make a scatter diagram for this. Let's do that. So you're gonna have what? You're gonna have a y-axis and an x-axis, right? This is my x, this is my y, right? Nothing new here. Remember this, right? Now I have to make my, I'm about to say bounds. I have to make my the numbers on my axis. I have to write the numbers on my axis. That's what I'm trying to say, right? I have to be sure to include the largest number in my data set. So let's look at the X's right here. I have 5.2, 7.3, 6.7, 5.9, 6.1, 8.3, 5.5, 7.0. The largest number there, 8.3. So what does that mean? I need to figure out a way on how I'm going to get from 0 to at least 8.3 or better, right? It's not. But we did this all already, right? Go ahead. Mm-hmm. Mm-hmm. Well, no, I'm not on the Y yet. I'm just looking at the X's. Yeah, the X's. So I'm starting right here, right? I'm trying to figure out how to go across the X-axis, right? How to increase it by, do I want to go by ones? Do I want to go by twos? Do I want to go by fours? You know? Two is good. All right, so let's do that. So this would be two, this would be four, this would be six, this would be eight, this would be 10. All right. Yeah, throw with me. Now, now I'm looking at the Y's. Let's look at the numbers that we have for the Y's. I have 3.3, 5.9, 4.8, 4.5, 4.0, 7.1, 3.6, 6.1. So my largest number there is 7.1. So I have to figure out how am I going to get from 0 to 7.1? Do I want to go by ones? Do I want to go by twos? Do I want to go by fives? Do I want to go by tens? All right, let's go by twos. All right. So let's do it. If I have 2, 4, 6, 8. I don't have to do 10, but I'm gonna do 10. All right.
Just for reference, the
Mhm.
graph could be any graph, right? It
What do
could
you
be, the graph could be set up any way, or it has to be set up like this.
Like you mean like in terms of the numbers that I'm increasing it by? Like
No,
what
but
number?
basically,
Mhm.
well, it's like a cross, right?
Yeah, yeah.
Would it
The
ever be
x-axis
cross?
is always on the bottom and the y is on the side.
Okay, so I can
Yeah.
expect on the test to
Yeah.
see the slope one,
Right.
which is the
It'll look
crisscross.
just like this. Or at least that's what I expect you to draw from me. You know? So after that now, right? You guys remember the points X and Y, right? These are your pairs right here, X and Y. So you go across on your X axis, then you go up on your Y axis. So I'm going to go across the 5.2. I figure 5.2 is in between the 4 and the 6, right? But a little bit more than five than the middle. So 5.2 and then 3.3. So I figure that's going to be somewhere like here. And you just make a point. And you do this for every single point, right? X first, then Y. X first, then Y. Next one, I got 7.3, 5.9. Mm-hmm. Go ahead.
So when you say 5.2 for X, that don't have nothing to do with the Y, correct? That is our text point.
So, right. So for the X, I go across the 5.2, let's say right here, and I go up to where I believe the 3.3 will be. And that's it. Yeah.
To get the
Yeah.
response.
Yeah.
Okay. Thank you, I'm sorry.
Same thing like what we did before. We're just plotting the points. That's it. Right? Let's do the next one. 7.3, 5.9. So I go across to where I think 7.3 is. I go up to where I think 5.9 is, make a mark. Right? You can make dots. I just like to do X's, you know? 6.7, 4.8. I feel like that's like here. 5.9, 4.5. I feel like that's like here. You know, it doesn't have to be perfect. Just do your best. All right. 1, 2, 3, 4. Next one, 6.1, 4.0. 6.1, 4.0. I feel like that's here. 8.3, 7.1. I feel like that's like here somewhere. 5.5, 3.6. I feel like that's here somewhere. 7.0, 6.1. I feel like that's here somewhere. You get the idea, right?
Yeah.
This is a scatter plot. This is it. All right. One thing that I will ask you when you're doing this is to label your graph, right? So what did we say X was? X is the inlet where the dirty water is going in, right? So this is my inlet, right? In 100, I forgot what it was, milligrams per liter.
Professor, can I see
And then
the
this would be
top?
my outlet. I'm sorry?
See the top really quick so I
Yep.
can grade it?
I got you. And then this is in 100 milligrams per liter.
And you got that paragraph, right?
Exactly.
Okay, so we're basically following what the paragraph and the number graph says.
Exactly. This is it in a nutshell. Any questions on the scatter diagram?
This is way easier than slope.
This is it. Yeah. Just plot the points.
Oh, you do, that's like less steps.
Less steps, exactly.
Or is it easy because we did the slope already?
I'm gonna do solo frequency, that just.
I agree.
Frequency is fucking terrible.
I agree.
Like, it's just taking like each time you can't mess up as one point, you just.
It throws off the whole thing.
Once
I
you
agree.
make one mistake, you're not getting anything right.
Right.
Nothing.
So there's no questions on the slope, we get it? Slope, excuse me.
No, I.
There's no question on the scatter diagram?
This perfectly, but I actually can't slope all the way.
That's fine. So this is it in a nutshell. Well, sure. Go ahead. That's the question.
Oh my god. Every time I come to school, my ass was bad.
Really?
Yeah, it's only when I'm in here, I'm fine when I'm outside.
I got you. So here's the next question I'm gonna ask you, right? Whenever we're doing this. 1 second. Let's copy that. All right. So this is our graph, right? Now, what I want to know is what is the trend of these dots that you see here, right? Would you say that this graph or whatever, this data, would you say that it's increasing or decreasing? Increasing, right? So if there was a line that would go through it, the line would kind of represent it go like this, right? Like it's increasing from left to right, right? That's good. So that would be the second question I ask you about a scatter diagram. First is to plot it. The second question is I would ask you to estimate, right, the correlation coefficient, which is basically I'm asking you what is the trend of the dots? Is it increasing or is it decreasing? Right? So you tell me that the trend is increasing, right? So, or the correlation is increasing. A third question that I would ask you after that, right, is explain it to me, right?
Explain to you why it's increasing?
Like interpret it. Maybe that's a better word for it, right? So here's the interpretation, right? As X is increasing, Y is increasing.
And so the other
Right.
pattern would be vice versa, right? Like some.
A little bit different. If it was decreasing, as x is increasing, y is decreasing. So if it was a negative slope, right, it would say as x is increasing, y is decreasing. Right? For a negative slope. Obviously, though, we're doing this on a test, right? I don't really want you to use x. I want you to use what x is. So x is the inlet, right? So as the inlet is increasing, the outlet
Oh, right, so.
is increasing.
Whatever the question says, that you.
Right, the story.
It's gonna tell us.
Right,
What it is, we need to make sure that we enter those details.
exactly.
Okay.
This is the whole scatter diagram. That's it. So you're gonna plot it. I'm gonna ask you what's happening with it, right? What's the trend? Right? The homework too, same thing, right? What's the correlation? Mhm. I feel like trend makes more sense than the word correlation, but I'm gonna explain correlation a little bit more, right? But it's the trend, right? What's it doing? Is it increasing or is it decreasing? Right? Yeah.
Anything you've taught us.
Really? That's
Really.
good. It's the hardest question on your final. Yeah.
Professor,
It
you.
It really is.
Professor's funny.
Yeah.
Child, you making me so nervous about this test.
Yeah.
And it's like one straightforward one, no
Mhm.
extra.
Yeah.
Extra like steps.
Exactly.
Just do this.
Just 3 questions. That's it.
So simple.
So real quick. Y'all know my drawing not that pretty. This is what it was supposed to look like if I was a computer, right? Right? So it's supposed to look something like this, Like, but as long as it you get the idea, that's all that matters, right?
Negative, how would it?
So it would be going down, like the other way. Yeah. So you read the graph from left to right, the same way that you read a book, right? From left to right, right? So if it was negative, right, the dots would be like this or whatever, and then there'll be a line going down. Like that. Yeah. 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 That's it. Yeah.
Fine.
So yeah, that's what it was supposed to look like. Right? Hmm. So I started from 0. You could skip a few numbers and start a little bit higher if you want.
Oh, yes.
There'll be a graph on the test. Yeah, there'll be a graph on the test.
Semi okay with this. Can we go through slope really quick?
Yeah. The slope is what I just asked you. Is it increasing? Yeah,
Like
yeah.
the 5.2 to 0.
No. When I asked you what the trend is, that's the slope question on your test. Is it increasing or decreasing? That's it. That's it.
BMX, YX, take away Y2.
But remember, it's on your formula sheet.
Professor.
Yeah.
Yeah.
Really?
Thank you.
But it's right there. It had everything on it. Had everything on it. Yeah. I promise you.
That's why I'm.
Yeah.
Did anyone vote so I could join you? Did anyone sign the chapter to read next week? You promise? What's the Wednesday? Today's Wednesday, yeah.
All right, let's talk about the interpretation.
Listen, if you're gonna do it, tell me. Yeah. I could, it's the morning.
So I'm gonna elaborate on the interpretation a little bit, even though I told y'all how to do it already, right? So here we go, interpretation, right? So comment on the relationship between the x and y in the figure above, right? By inspecting the figure, we see that smaller values of x are associated with smaller values of y, and larger values of x tend to be associated with larger values of y. Regularly speaking, the general trend seems to be reasonably well represented by an upward sloping line segment as shown in the diagram, right?
Professor, if you would have shown me this before this example, I would have told you, I don't know what the hell you do.
Really?
Yes, cause why does it have to be so fancy? Why can't it be dumbed down?
Hmm.
It's too fancy for me. I don't get
I
it.
thought my way of explaining was more fancy.
You're a mathematical genius, you are.
I got y'all. So
It's gonna warm up and, no, it's cold. It's definitely good.
I don't know, this a funny month. This a funny month. All right, so look, of course, it is possible to draw many curves close to the points in the figure, but a straight line is the simplest and most widely used in elementary studies of paired data. We can draw many lines in the figure, but in some sense, the best line should be the one that comes closest to each of the points of the scatter diagram. So to single out one line as the best fitting line, we must find a mathematical criterion for this line and a formula representing the line. So this is going to be done in the next section, right? Using the method of least squares. Mhm.
I'm sorry. Is the dumbed down version of this that you're trying to tell us is to just make a straight, a crooked line in between the points like you did up there?
Mhm.
See? That's
So what
fancy.
what they're trying to say, right, is I could have a scatter plot, right? But there are different graphs that I could use to represent the data, right? Remember like how you learned parabolas, right? And we learned yeah, like yeah. So look. Right, right. So a straight line is the easiest way to like estimate it, but there's other graphs that could be used too. Like you have graphs that look like this, for example, right? You have graphs that look like this. You have graphs that look like this, right? No. I'm just saying that there's other ways that you can represent this, right? Exponential, quadratic. There's different kinds, right? You guys will see that when you guys go to your next statistics class. Mhm. Yeah, yeah. Oh, yeah, y'all got a part two at the 4-year school. Everybody does. Yeah. Hey,
Oh, I know
yeah.
this is my last class.
You got more in the future. Yeah, yeah, yeah. When you go for your nurse practitioner, you're gonna have more.
Well, I actually want to be a nurse
Yeah,
practitioner.
yeah, we got more. We got more. Yeah, yeah. Sorry, look. Another problem precedes that of finding the best fitting line. This is the problem of determining how well the points of the scatter diagram are suited for fitting any line, right? Certainly, if the points are a very poor fit of any line, there's little use in trying to find the best line, right?
So it don't matter, basically. And
It
dumb down
it
way.
matters. It matters. I wanna see how closely related two sets of data are, you know?
You mean, no.
Say it again? Wait, say it again. Wait, because I wasn't looking, I only heard you. Yeah. 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 So x-axis is the horizontal one, y-axis is the vertical one.
Yeah.
Yeah.
But I is always the first one, and then comes one.
Yes. Mhm.
Says write down the
I got you.
down versions. It will help you.
So if the points of the scatter diagram are located so that no line is realistically a good fit, right? We then say that the points possesses no linear correlation, right? And we see some examples of scatter diagrams like this, right? So like let's look at A, right? It looks parabolic, right? But that's not linear. That's the whole point. Or B, this is a scatter diagram too, where we can't even tell what kind of correlation that is, right? That's just looks like zero, right? So if the points seem close to a straight line, we say that the linear correlation is moderate to high, depending on how close the points lie on to the line. If all the points do, in fact, lie on a line, then we have perfect linear correlation, right? So in the next figure, we're going to see some diagrams of perfect linear correlation. In statistical applications, perfect linear correlation almost never occurs, all right? So basically what I'm about to show you is just some made up, the perfect linear correlation is made up, basically, for lack of a better term. Hmm? Yeah. It's like saying hypothetically speaking, a perfect correlation could happen, but that's not gonna happen in real life, kind of situation. Another example too is no correlation. The idea of zero, like when you look at part B right here, like you would look at part B and you would say like, oh, that's zero correlation, right? We can't tell if it's positive or negative. In actuality, there is an actual mathematical formula that can determine what it is, whether it's increasing positive or decreasing negative, right? So what I'm trying to tell you is that there is no such thing as zero correlation. Just like there's no such thing as perfect correlation. Those are like textbook examples, you know? Yeah. Mhm. Mhm. Yeah. 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 I mean, we're gonna do it in here.
So if
Yeah.
the dots almost
Mhm.
make a straight line,
Mhm.
that means that.
If they fit on a straight line.
Right, if
Yeah.
you're like closer to the,
Mhm.
then you're gonna have a moderate to high
Right.
correlation.
Right. Yeah. So the variables x and y are said to have positive correlation if low values of x are associated with low values of y and high values of x are associated with high values of y, right? This next figure in A and C show scatter diagrams in which the variables are positively correlated. On the other hand, if low values of x are associated with high values of y, the high values of x are associated with the low values of y, the variables are said to have to be negatively correlated. And then example B and D is going to show you that. So this is A and B. This is moderate linear correlation, right? So you see the dots, they're increasing, positive correlation. This is an example of negative correlation here. The dots are decreasing the ones. Now let's look at what perfect correlation is.
So would.
That doesn't happen in real life.
Would A be like a moderate to high and B, they're both moderate.
Exactly. One is moderate high, the other one's moderate low.
Oh, okay.
Yeah,
So the negative is moderate low
right.
and the regular is positive high.
Moderate high. Yep.
Sorry.
Yeah. And then this is perfect correlation. This is something you'll only ever see in a theoretical textbook, right? Mathematically, it makes sense. Realistically, it'll never happen. All right. So this is perfect correlation. This is like
And you said.
positive correlation.
The negative and the positive is moderate. Positive.
So this is moderate positive.
Okay. And you're expecting for us to say that?
No,
Okay.
I'm just telling you what it is. All I'm gonna ask you is, what would you estimate the trend to be? What would you estimate the correlation coefficient to be? You tell me back, positive or negative. That's it.
Say increasing or decreasing?
That's fine.
That's fine?
Yeah.
Okay, because I might.
That's all I'm asking
confused
for.
if I try to throw positive.
That's all I'm asking for. All right, let's sum up the scatter plot real quick. All right. And then we get to talk about R.
Right, you got me feeling hopeful with this correlation stuff.
right? People do this stuff all the time on TV. So what does a scatter diagram tell us, right? A scatter diagram shows the relationship between two paired data values, right? Variables, excuse me, X and Y. For each pair, X, Y, of the data set, we plot the point on the grid with horizontal axis X and vertical axis Y. So to the extent the data values of the graph fall closer to a straight line, we say that the relationship between X and Y is more linear. To the extent the data values are scattered over the graph, we say no linear relationship between X and Y is apparent. All right. One sec. Now, how do we, if we have one of those crazy graphs that looks like zero, like no correlation, right? How do we determine if there is a correlation, right? So there's a formula, right? We call this the R formula, right?
Wow. This is the same thing as high and low correlation, no?
Mm-hmm.
Because basically, you just gave us the same definitions in just different words.
Exactly.
Right?
Yeah, exactly. So this R formula here, this is how you determine, right, what the trend will be, mathematically speaking, right? So sample correlation coefficient R. Looking at a scatter diagram, we see whether a line best describes a relationship between the value of data pairs is useful. In fact, whenever you are looking for a relationship between two variables, making a scatter diagram is a good first step. There is a mathematical measurement that describes the strength of the linear association between two variables. This measure is the sample correlation coefficient R, right? The full name for R is the Pearson's product momentum correlation coefficient, named in honor of the English statistician Carl Pearson, right? Rest in peace, who is credited with the formulation of R, right? I got you. This is a mathematical formula to measure the strength of the correlation, right? I want to see how well two situations are paired with one another. Mhm.
Oh, it's so good to
Right.
meet you.
So let's look. The sample correlation coefficient R is a numerical measurement that assesses the strength of a linear relationship between two variables X and Y. R is a unitless measurement between -1 and 1. In symbols, -1 is less than or equal to R, which is less than or equal to 1. If R equals 1, there is a perfect positive linear correlation. That'll never happen in real life, right? If R is equal to -1, there is a perfect negative linear correlation. That'll never happen in real life. If R is equal to 0, there is no linear correlation. That too will never happen in real life. All right? It'll always be in between. The closer R is to 1 or to -1, the better a line describes a relationship between the two variables X and Y. Right? I got you. We're gonna do one. 2, right? Positive values of R implies that as X increases, Y tends to increase. Negative values of R imply that as X increases, Y tends to decrease. Right? So my question that I'm asking you when I ask you what is a trend, I'm asking you to estimate what do you think R would be? Do you think R would be positive or negative? That's all I'm asking you to do.
Or number, you just want negative or
I don't want the
positive.
number. No. But I will show you how to get the number. All right. So the value of R is the same regardless of which variable is the explanatory variable, X, and which is the response variable, Y. In other words, the value of R is the same for the pairs X comma Y and the corresponding pairs Y comma X, right? So let's get deep for a second, right? When they first made this Cartesian plane, right? You remember we talked about Rene Descartes and how he made the Cartesian plane with the X and the Y plane and all that? when he made it originally, he didn't actually have an orientation. So he didn't actually say that, all right, X is definitely here and Y is definitely here. It could have been flipped for all he cared, right? And when we talk about scatter diagrams, that same definition is true for here, right? If I'm trying to find a correlation between, let's say, studying for a test and the test scores, it makes no difference if I look at the test scores and studying,
Yeah.
right? Yeah. So that's what I'm trying to say. Like if I switch the variables around,
It doesn't.
it doesn't matter, right? It's the same correlation, right? Um, the value of R does not change whether the variable is converted to different units. All right. Fun stuff, fun stuff, fun stuff.
Not fun, it's
It
so-
is.
You gave us something so easy,
Yeah.
but you made it so complicated.
You think so?
Yes,
I think this is fun.
you gave me hope.
This is really fun. If I had more time, I'll show y'all how to use this information to make money.
Nice. Well, I want you to.
Nah, real money, legally. Yeah.
It's a sample of this, because I'm not.
I got you.
all the way.
I got you. We're gonna look at some more.
This will have a straight, a crooked line like the one we just had, right?
Mm-hmm. Say it again. FanDuel? We could use this to do FanDuel. Yeah. Sports betting. Yeah. It's anything, any sport. Yeah. Right? So yeah.
That's great.
So just so we clear, right? 2026 Knicks for the finals, right? Yeah, Knicks for the finals. Oh man. Football,
Love the cheese, that's what they,
Chiefs.
yeah, they're so good, I love them.
I love the Jets.
The
Yeah.
Chiefs are really freaking. Yeah.
I seen videos of them winning.
No.
Right. So positive linear correlation, high X, high Y, low X, low Y.
But when I want the whole thing on the back, so was that one, the picture, no, just going at that. Yeah, it was one, right?
So, and I'm still stuck on the one that they won, and I thought they won last one.
So this is an example of positive correlation, positive linear correlation right here. You have high X, high Y, low X, low Y. Let me show y'all what negative is like.
So I'm a fifth grader.
Mm-hmm. Yeah. I'm kind of just like beating a dead horse right now, saying the same thing again. All right. Yeah. So this is the reverse. Mm-hmm. Mm-hmm. So negative linear correlation, right? You have a low X, high Y, and you have a high X, low Y. All right.
If the top one is eight, no,
Mm-hmm.
can I do the top one?
As X is increasing, Y is decreasing. Just think of it like that.
You did, right?
Exactly what we did. Mhm. I'm just saying it in a more complicated way, but it's the exact same thing. See you. Mhm. Exactly.
So we not having, that day, you don't even know how they for equations like this.
But I'm confused about that R stuff you just gave us.
Yeah, because that's what you about to look at.
Yeah, that's what I'm
Yeah.
kinda like.
We gonna get into R. Don't worry. R is really cool. All right. So this is what little to no linear correlation would look like. Just scattered all over the place, right? We have a low X, high Y, we have high X, high Y, we have low X, low Y, we have high X, low Y, right? So this is what you would say is little to no linear correlation, right? Just an example. All right. Let's see if we can talk about R a little bit.
But can we talk about it with the simple one you gave us, not
Hmm?
this?
I'm gonna use simple numbers.
Oh, we done, that's the classes always.
Let's talk about it for the next class. All right, we can do it next class. I wanted to show y'all the formula for R though. The formula. All right, let me show y'all the formula real quick. So look, computation formula for R, right? So this is the mathematical formula. So the defining formula for R shows how the mean and standard deviation for each variable in the data pair enters into the formation of R. However, the defining formula is technically difficult to work with because of all the subtractions and products. A computation formula for R uses the raw data values of X and Y directly, right? So that's what I want to show you guys, the simple computation formula. All right. It involves X's and Y's. Yeah.
So it's
So I'm going to show you the simple formula.
close to the zero.
Mm-hmm.
No, wait, if it's like decreasing, then it's gonna be negative, it's a.
Exactly.
Increasing, it's gonna be positive.
Exactly.
But you don't need a number, you just want us to say positive or negative?
That's it. That's it.
Why
But I-
do you
but
feel
um
like you're trying to-
but I'm showing you how to get the number, right? That's what the R is. No, for real. That's it. Huh? Look at chapter 4 in
Yeah, 4.5, right?
4.1, we're 10 big one. Right? So procedure, how to compute the sample correlation coefficient R. Here we go. Obtain a random sample of n data pairs, x comma y. The data pairs should have a bivariate, normal distribution. This means that for a fixed value of x, the y values should have a normal distribution or at least a mound-shaped and symmetrical distribution. And for a fixed y, the x value should have their own approximately normal distribution. All right, so here goes the formula for R. Then we'll talk about it next class. All right. This is really fun. You got it. I hear someone saying it. It is.
Be on the test, you're only gonna ask us if it's positive or
It's
negative.
on the test, but all I'm asking you is a sign. Yeah. So here goes the procedure. Yeah. So that's it.
I think we can do this on the calculator.
So we're gonna have our data pair values, right? We have our sum of x, our sum of y. Then we square those. Then we have our sum of x squared, our sum of y squared. And then we have our column where we multiply x times y and we sum that up. After that, you just plug it straight into the formula, right? Here's the formula. Remember, n is your sample size, by the way, right? So R is equal to n times the sum of x times y minus the sum of x times the sum of y divided by the square root of n times the square root of x squared minus the square root of, n times the sum of x squared minus the sum of x squared times the square root of n times the sum of y squared minus the sum of y squared. Be careful, the notation sum of x squared means first square the x and then calculate the sum. Whereas the sum of x squared means first sum the x values and then square the result. All right, that's R.
Peter, what my,
I got you. Just use the fraction button. The fraction button. The fraction button. The one above the 7.
but aside from the function button,
Mhm.
if I wanted to just, how do I explain it? Like the standard deviation,
Mhm.
that's a thing on the calculator.
Mhm.
Is this a thing on the calculator?
Mhm.
So if I YouTube it, I just gotta put R formula, that's it?
I guess. Or you could just wait for tomorrow.
No, I'm not.
All right, I'll see y'all. All right.
So.
I got you. Have a good night, everybody. Good.